everybody, welcome back to another fun and exciting pre-algebra class. Today we'll be jumping into chapter number 12. Congratulations, you have made it to the end of the book. Good job. We do have to finish this chapter though, however. Sorry to disappoint you. But we do have to finish the chapter. There's only a few lessons in this chapter. You can do it. Finish strong, okay? You should be proud of yourself for working as hard as you have through this year. So good job. Lesson number 1 in chapter number 12. Chapter number 12 in general talks about systems of equations. What is a system of equations? Well, a system of equations is when and you can take a look down here at the screen or there in your book to find the definition. A system of equations is when you have two or more equations that have the same variables and are graphed on the same plane. You're like, oh no, are you serious? We're back to graphing? Yes, we're back to graphing. Some of you are like, oh no, anything but graphing. And then others of you liked graphing. So whichever kind of side of the fence that you're on there, we do have to get through this chapter. Really, as far as the chapter goes, this first lesson is really the only one that's going to be dealing with graphing. The other ones will find the solutions in different ways mathematically. So if you like graphing, today's your day. If you don't like graphing, just kind of get through today, and then you'll be able to do some other things in the next few lessons. All right, so when we're dealing with a system of equations, here's kind of the concept. Let me show you the concept. So if we have a Cartesian plane, I'll just throw a Cartesian plane out there, and let's say we have this pink line, and it just, randomly, I'm just drawing a random line. Then, and so this line would have an equation, right? So this line, the pink line, would be like y equals, I don't know what it is. Looks like y equals about I'll say negative 1/2 x plus 3. Okay, so the y-intercept is at 3. That would be right there. And then you would have a negative 1/2 slope and, something like that. So basically, if you remember from the graphing chapter, every line that we draw has an equation with it. So here's the idea. We would have another line on this graph somewhere, right? And here's the thing, no matter where we put this, it will intercept at some point. Because even if we put it like this, you're like, no, that doesn't intercept. Yes, it does. It just intersects. Like, you had to continue this pink line, and then you'd have to continue the yellow line, and at some point it will intersect. So really, every line is going to intersect, except for, there's only really one, I guess, exception to this rule, and that would be if you have what's called a parallel line. Those would never intersect. But for the most part, and you say, well, what about a line that was like directly on top? Well, technically that's intersecting everywhere. It's like infinite intersections. So really the only time that a line would not intersect on the plane somewhere would be if you have a parallel line. So let's just kind of throw a line in here, and I'll just put it something like this. And I won't make up an equation for that line, but the concept is that both of these lines have an equation. The solution, the way that you solve these, is you are looking for where does it intersect? Where does it cross? So I think I called this like 3. Okay, so this would be 1, 2. Well, let me actually put these down here. 1, 2. So this thing would be intersecting. Look, we're going up. Well, we're going left, 1, 2. So it would be negative 2 on the x. And it would be what? 1, 2 on the y. So it would be 2, 2. This intersection would happen at negative 2, positive 2. Negative 2 on the x, positive 2 on the y. That's the concept of intersection. That's the concept of systems of equations. Now, there's tons more to talk about with that, and we will talk about that as we go through the lesson, but I kind of wanted you to have just like a general concept in your mind of what am I even talking about right now. What I'm talking about is 2 lines that cross each other, maybe 3 lines that cross each other. I mean, think about this. Like if I have so I have one line here, and one line here, and maybe I have another line here. And I could have, I mean, this line could be wherever, and maybe it doesn't cross both lines in the same place. Maybe it does. But so we can have different types of systems of graphs. We can have even three-dimensional systems of graphs that we'll get into later on in different levels of mathematics. But for right now, the concept is a system of equations is when two or more equations have the same variables and they're graphed on the same plane. What happens is typically, unless it's parallel, you get an intersection. You get it where it crosses. There are three ways to solve systems. Okay, you probably want to write these down. And these are going to be your next three lessons. Today's lesson is going to be on graphing, and then we'll do a lesson on substitution, and then we'll do a lesson on elimination. These are just three different methods of solving the same problem. Here's the cool thing. You will get the same answer if you choose graphing, if you choose substitution, or if you choose elimination. I mean, you'll get the right answer if you do it right. I mean, you do have to do the problem correctly to get the correct answer, right? So, if you do it correctly, you can choose whatever method that you want, whatever method's easiest for you, and you can solve your systems whichever way you really want to. Now, on a quiz or a test, I might say, or the book might say, hey, do this with elimination, or do this with graphing, whatever it says. You'll have to do it like that in order to get credit for that question. All right, so today's lesson, solving by graphing. What we're going to do is we're going to graph both equations on the same Cartesian plane, kind of like I did in that example that I just did for you, kind of where I just roughly threw the lines on the graph. We put both lines on the graph. That's the first step. The second step was to locate their point of intersection, or where they cross. Where do these things cross each other? Locate that point. That's your answer. That's your solution. Your solution to a system of equations is the crossing point, okay? The intersection point. Number three, we want to check our solution by substituting in the point of intersection to see if it satisfies both equations. You'll see what I mean by that in just a minute. But what should happen is, if you're correct, your answer should go into both equations and it should work in both equations. Why? Because that point that you picked is contained in both lines, because that's the point that it crosses. All right, what do I mean by that? All right, so if I have my Cartesian plane, and I have this line here, and I have another line here, this point at which it crosses, okay, so this point right here, notice this point is on both lines. That blue point is on the purple line, and the blue point is on the pink line. It's on both lines. So in other words, when we check that solution, it should work with both equations. Why? Because it solves, or it satisfies, both equations. All right, let's go ahead and try one of these. Pretty much every time that you see a system of equation, it's going to have this thing on there, and I am terrible at drawing that thing. I don't even know what it's called. I'm not an art major. I'm a math teacher, so don't laugh at my little drawing over here of that thing. It's like a little bracket thing that includes... I'm sorry. All right, so yeah, if you can do better, yeah, you go ahead and do better. But anyways, when you see that, when you see this thing right here, it's letting you know, hey, these two equations right here, these should be together. These should be graphed together on the same graph. So here's what we want to do. We want to talk about, how do we graph these equations? It's been a while since we've done any graphing. I know it's back a few chapters, but one thing that you can always do is go back in your book, review how to graph. There's really two ways that we talked about with how to graph. We said that you can graph it from right here. This is what's called the y-intercept form, or you can graph it with a x and a y chart. like this. Here's what I'm going to do. I'm going to graph one of them from y-intercept, and I'm going to graph the other one from the x and the y chart. I'm going to graph this one from y-intercept, and I'm going to graph this one from the x and the y chart. So let's go ahead and let's do the first one. Let's go ahead and get that graphed. So let's switch over here to our graph paper. This is a system of equations, and what I have here is I've kind of put the graph paper up there. I put my Cartesian plane right here, and now this over here, these are my two equations. I want you to see they're kind of joined together by this little bracket right here. I'm not very good at drawing those brackets, okay? So some students laugh at me when I try to draw those because they always look goofy, but you know, hey, maybe you can do a better job. I'm sorry, I'm not an art major, I'm a math teacher. So that's what you got right there. Little bracket. What they do is they connect these. In other words, they kind of say, okay, these two equations, they're together. So now what we want to do is we want to graph both of those. You may need to kind of look back in the graphing chapter that we did. You may need to look back in your book. You may need to review some of those videos that I did back there if you don't remember how to graph. Here's what I'm going to do. I'm going to graph this first one using the y-intercept form of graphing, and I'm going to graph the second one using the X and Y chart method of graphing. So I'm going to use both different methods that we learned, and we'll kind of work through that one together. Okay, so this first one, we'll call this the green line, and so we'll do this one in green right here. So the first thing that I notice is that we are in y-intercept form. We have y equals mx plus b. Remember, the b is our y-intercept. The x is our slope, so we're going to be able to use both of those in our graphing. So we want to put a point at 1 on the y line. So we're going to put a point right there at 0 on the x, 1 on the y. Now we come over here and our slope is 1/3. So that means that we go up 1 over 3. 1, 2, 3. We're going to end up right there. And then we can keep going with that if we want to do another one. And the reason why, remember, our slope is written as y over x, or rise over run. So this is the rise, this is the up and down, and then this 3 is our left and right. If it's positive, then we go up. If it's negative, we go down on the run. If it's positive, we go to the right. If it's negative, we go to the left. Hopefully you remember that. So we could put one more point on here if we want to, and we would just do this again. So we could do 3 first this time. We'll run 3, 1, 2, 3, and then we'll rise 1, and there is another point on our line. So now what we're going to want to do is basically just take our, our line and go ahead and go through our points right there. Okay, it's pretty close, not perfect, but you do better on yours. Next one we'll do in purple. Now, you probably see why I like to graph in the y-intercept. It's fast. It's easy to graph. You just have to remember, okay, what's this? That's the b. That's the y-intercept. What's this? This is the slope, y over x. If you can remember those things, then you can graph in that. This one we're going to graph with the x and the y chart. So I'll do an x and a y, and we'll do a chart. Remember I said, always start with 0 because it's easy. You don't have to. You can start with 1, but you want to start with a number, and we're just going to substitute it in for the x. So y equals -2 times 0 plus 8. -2 times 0 is 0 plus 8 is just 8. So y equals 8. So when x equals 0, y equals 8. Now we're going to do it again. We're going to do this one 3 times just to make sure that we don't mess up. That third time just kind of checks it. Let's do a 1 this time. So 1 plus 8. So -2 times 1 is -2 plus 8. -2 plus 8 is 6. So y equals 6. When x equals 1, y equals 6. We'll do it one more time. And this time we'll do 2. So 2 times -2 is -4 plus 8. -4 plus 8 is 4. So y equals 4. All right, so there are my points that I'm going to graph, and I'm just going to graph those now in this purple color. And so I'll just go 0, 8. So that means 0 on the X, 1, 2, 3, 4, 5, 6, 7, 8 on the Y. So we'll go with a point right there. Let's get rid of this. And then the next one is 1, 6. So we'll go over 1. 1, 2, 3, 4, 5, 6. Go right there. And then the next one, the last one, is going to be 2, 4. So 1, 2 on the X, 1, 2, 3, 4 on the Y, and we'll end up right there. All right, now when I draw this point, what you're going to see is this is actually going to intersect. This is going to cross. And so let me kind of focus in on this crossing point right here. This crosses right here at this point. We actually already had a point right there, but I'm going to put a pink X right there, a pink dot. So, you know, that's kind of like X marks the spot right there. And that is our solution. Why is that our solution? Because that's where they cross each other. So the only thing that I would do now is I would just figure out, okay, what is that point? So let's look. 1, 2, 3 on the X, 1, 2 on the Y. So our solution would be 3, 2. That's our solution right there. Now, I said earlier that you can check your solution. Let me kind of get rid of the graph because we won't use the graph to check it. Hopefully you kind of understood what I did there with the graph. That's how we got our answer. And now what we want to do is check it mathematically. So I'm going to take this and I'm going to plug it back into this equation. And then I'm going to plug it back into this equation. And if I did it right, it will actually solve, or you'll see it, it's what's called satisfy both solutions. So y is 2, okay, right there, y is 2, and that equals negative 2 times x. X is 3 times, or plus, excuse me, 8. So we just want to do this. 2 equals, this would be first, that would be what, negative 6 plus 8. 2 equals negative 6 plus 8 is 2. 2 equals 2. Yes, we got it correct. Both of them worked. So that when I checked the solution, it worked. It satisfied both of those equations. And so, in other words, we were able to get our answer correct. Why? Because we found the point that it crossed, and then we checked that point into the equations. Okay, does it actually work? Does it solve that? Does it satisfy that equation? The answer was yes. All right. So hopefully you learned something there. I know there's quite a bit of information, but it's stuff that we've kind of done before. There wasn't anything really new there, but it has been a while since we've done those. So go back, review those things, study, try those, practice. And if you missed anything, slide this back, watch it again, and keep trying, keep practicing until you get it right. That's all I got for you. Have a good one. Bye-bye.